Nested codes. If you're looking to get absolute numbers of codes, codes with transcripts, or compare one coder to another, we have other functions and other tutorials for that. Please take a look on our YouTube channel. Once you're in vNote and you have your video associated, you're ready to begin making labels and sublabels. Simply click on the plus sign and you will create a sublabel to that particular label. Alternatively, you can right-click while over the gray part of the labels on the left and click Add Sublabel. And here we've got it set up for a baseball player called Jones for an example. Note that there are different levels of subcodes or sublabels. When you're ready to begin making codes, just click the hotkeys on the keyboard associated with what you want to label. You can click on Make Same as Parent, and that will not allow the dependent labels to overrun or exceed the bounds of the parent labels, which can be useful in certain circumstances. When you are coding your video or generating labeled instances on the video timelines, you can press two buttons or multiple buttons at the same time. Again, you can use the feature where the children will be limited by the parent labels, which can help you as well. Here we've got a scenario where some sample data has been generated for this baseball player. So we have Jones and up to bat, as well as other codes like hit and foul and run. In order to analyze the data and the relationships between different hierarchical codes, you have two options. Click on File at the top, Nested Statistics, and then choose Number or Time. We will show examples of both. Here we have an example in which the codes are compared by number only, not at all with respect to time. And as you'll notice on the top, there are 3 codes for Jones, 2 codes for up to bat, 4 codes for hits. And we can see how that will appear in the statistics just exported and opened in Excel. 2 out of 3 is 67%, as indicated in the upper left of the Excel file. Next, take a look at hits. Note that there are 4 labeled instances in the hits timeline. We can now see how those 4 instances relate to the instances above them by comparing them. We can see in the column relative frequency to level 1, 133.33%. which means there are 4 hits to 3 labeled or coded instances of Jones, providing a 1.33 ratio or 133%. We can also see that there are 200% relating to level 2, which is up to bat. So he was up to bat twice, and there are 4 hits, therefore 200%. And you'll note that it continues like this, where all layers or levels of codes are related to the codes above. Next, let's take a look at the other statistical function that permits you to compare and relate the time of one code versus the time of another. Here we show time spent singing by the entire group, as represented by the blue bar, or blue labeled instance at the very top line. Labeled instances below on other timelines, starting with yellow and ending with red, represent time spent leading the harmony by each individual singer. To find the time function, click on File, Nested Statistics, Time. This will output a file that you can open in your favorite spreadsheet program. Now we're showing Excel opened with our data on the top and vNote open on the bottom. First, we can see in the upper left part of Excel, level 1, group harmony, the percent time of the total video is about 24%. Then we can see in level 2, Amy, another singer, who's represented by the yellow labeled instance, takes 12.19% of the entire video leading the harmony. With respect to the total group harmony, she sings about 50% of that, which you can see by comparing the yellow line and the blue line. The yellow line is about 50%. With level 3, we can see that Brianna sings about 6% of the time of the total video. With respect to level 1, or group harmony, she sings about 25% roughly of the time, which you can see by comparing the gray bar to the blue bar. With respect to level 2, Amy, she sings roughly half as much as represented by the yellow line. This is obviously a very simple example chosen for clarity. If you, however, had 50 codes, their time would be summed and the same functionality would apply. For example, if the yellow labeled instance were broken into 50 parts and they summed to the same amount of time, all of the figures would be the same, whether 4 pieces or 50 pieces, or 1, as we see here.